Hi guys, integrate integral of square root of a square minus s square ds. We are going to integrate this using trig substitution method. Let x equal to a sine theta. Let's differentiate this with respect to theta. So that will be ds d theta equal to a is constant. Differentiating sine theta with respect to theta, we have cos theta. This implies that ds is equal to a cos theta d theta by cross multiplying. So from here we have integral of square root of a square minus s square. So in place of x we write a sine theta all squared times, and in place of ds we write what? We write a cos theta d theta. A cos theta d theta. Integral of square root of a square minus a sine theta all square is what? Is simply a square sine square theta times a cos theta d theta. Integral of square root of, what is common here? A square is common. We can factor it out. So that will be a square into 1 minus sine square theta times a cos theta d theta outside. Let's continue. Recall that sine square theta plus cos square theta is equal to 1. If we move sine square theta to the right hand side, we have cos square theta equal to 1 minus sine square theta. Take note of this. So from here we have integral of square root of a square. Now, what is 1 minus sine square theta? 1 minus sine square theta is cos square theta. So we have cos square theta here times a cos theta d theta. Integral of square root of a square cos square theta could be written as a cos theta all squared times a cos theta d theta. Integral of, clearly this bigger square root cancel out this power. We are left with a cos theta times a cos theta d theta. Integral of a times a square, cos theta times cos theta, that is cos square theta d theta. Also, recall that cos square theta is equal to 1 plus cos 2 theta divided by 2. This implies that integral of a square, in place of cos square theta now, we write 1 plus cos 2 theta over 2, 1 plus cos 2 theta over 2 times d theta. We can factor out a square. It is a constant. So we have a square times integral of 1 plus cos 2 theta divided by 2 d theta. Also, we can factor out these two. It is a constant. So we have a square over 2 times integral of 1 plus cos 2 theta d theta. Let's proceed further. A square over 2. Now, we can easily integrate our integrand. Integrating 1 with respect to theta, that gives theta, plus integrating cos 2 theta with respect to theta, we have sine 2 theta over 2. Close the brackets, plus constant of integration c. Also, recall that sine 2 theta is equal to 2 sine theta cos theta. This is a trig identity. So from this line, we have a square over 2 into theta plus. In place of sine 2 theta now, we write what? We write 2 sine theta cos theta. 2 sine theta cos theta divided by 2 plus c. A square divided by 2 into theta plus. Clearly, 2 cancels 2. We are left with sine theta cos theta, close the bracket, plus c. From our trig substitution, x equal to a sine theta. Let me show you where we got this. That's the first thing we did. This line. Let's continue. If we divide both sides by a, we have sine theta equal to x over a. Hope you got that. This implies that theta is equals to arc sine x over a. If you look at this line again, you will see that we already have what theta is. Theta is arc sine of x over a, and also sine theta is x over a. What we need now is cos theta. We can get it from this. Recall that sine square theta plus cos square theta is equals to 1. If we bring sine square theta to the right hand side, we have cos square theta equal to 1 minus sine square theta. So cos square theta is equal to 1 minus, what is sine theta? Sine theta is x over a, so we have to square it. So that will be s square over a square. Cos square theta is equal to, the LCM here is a square, so that will be a square over a square minus s square. But we need what? We need cos theta. Taking square root of both sides, cos theta is equal to square root of a square minus s square divided by a square. We have successfully obtained the value of cos theta now, sin theta, and theta. So let us plug all these values, all these terms, into this line. A square over 2 into, what is theta? Theta is arc sine of x over a, arc sine of x over a, plus, what is sine theta? Sine theta is x over a, x over a times, and what is cos theta? Cos theta is square root of a square minus s square over a square, square root of a square minus s square over a square. Close the bracket, plus c, constant of integration. Let's continue. This implies that a square over 2 into arc sine of x over a plus x over a times, this whole guy could be written as square root of a square minus s square divided by square root of a square, close the bracket, plus c. This implies that a square over 2 into arc sine of x over a plus x over a times square root of a square minus s square divided by square root of a square is simply a, close the bracket, plus c. A square over 2 into arc sine of x over a plus x over a times a square times square root of a square minus s square, close the bracket, plus c. Let us open this bracket. A square over 2 times this, we have a square over 2 arc sine of x over a plus a square over 2 times this, that will be a square over 2 times x over a square times this square root of a square minus s square plus c, constant of integration. Clearly, a square cancel a square. We are left with a square over 2 arc sine of x over a plus x over 2 times square root of a square minus s square plus c. This is the required solution for this integral problem using trig substitution method. That's it. Don't forget to like and subscribe to my channel.